Okay, folks, here's exactly where we left off before, um, because I stayed here. So somebody mentioned a median, and we'll get to that in a minute. Okay, our measures, excuse me, our descriptive statistics, n, how many numbers in the data set. Okay, the mean, which is also the average, and I'm not going to talk about what that means yet because it's a bit of it's a complex concept, even though the computations are pretty easy, right? You've done it for many years. The range, remember, the range is a single number. It tells us how many units in the number line the data traverse, okay? The data covers. So this range informs the mean. It tells us that this mean came from a lot of different numbers in our data in our number line. The mode is the most frequent score. That is the score that we see the most. In our data set, the mode is 8. And we'll get to the median in a minute, okay? Or a couple minutes. So we erase that for now. Even though I know the range is 8, that is, the scores go from 10 to 3. I still don't know if there was just one 3, if there were 10 3s, if there was just one 10, or if there were two 10s. I know that the most frequent score was 8, but of the 61 people, how many people reported a score of 8? Was it 12 people? Was it 27 people? Was it 53 people? Okay, I'm not really quite sure. So the range informs the mean, my highest and my lowest. I know that the most frequent score was 8. But does everybody see the problem here? Within this range, within the range of 8, I don't know how scores were distributed within that range. Okay? And this would be the same problem if the professor said, well, we have a mean of 75, and maybe even if the professor says, we have a mean of 75, and the lowest score was a 23%, and the highest score was 100%, you're still left sort of uninformed about, well, how were the scores distributed within this range of 8? Between 10 and 3, how were the scores distributed? And sometimes you ask that question in class. So I just want to make sure that people, I don't want people to be disconnected from this stuff. Statistics is a way to answer some of the questions that you ask sort of casually in the class. So you might say, well, professor, what was the average on the exam? They say 75. You might even ask, what was the highest score and what was the lowest score? But sometimes people who really want to know what's going on, they'll say, well, how many A's and how many B's and how many C's and how many D's and how many F's were there, right? What you're asking is, how were the scores distributed across those different levels? So we're going to do the same thing here for this data set. If I want to describe a data set, this doesn't do much. This helps us understand this. We might want to know the most frequent, but we still don't know. We know the highest score is 10, lowest is 3. But what's going on within that range, okay, within the range. So we're going to do something a little bit more complex now, just so that we understand the data set better. Okay, that's what descriptive statistics are about. Okay, so here's what we're going to do. We are going to create something called a frequency distribution table, okay? A frequency distribution table. And you should be taking notes. Let's start a new page. Let's start a new page, and we'll do the notebook landscape style, okay? Because we're going to have a bunch of different columns that we're going to put into this frequency distribution table. First column is going to be the X values. Now, I'm not going to list the 61 X values here. Let's remind ourselves that we have 61 in this data set. Okay. I'm going to start with the highest number, then the next. Oh my goodness. Can we see that? Yep. Okay. That is, these are our possible X values within the range. Highest number, lowest number. I'm always going to go highest to lowest, folks. Highest to lowest. The book goes highest to lowest. When I ask this question on the exam, some people go from lowest to highest, and it's always puzzling. I'm like, when have you ever seen that? That's not how it's done. There's a reason for that. We'll talk about in a couple minutes. Highest, and down to the lowest, okay? And then we're going to list the frequencies for each of these X values. What does that mean? How many people told me that they had happiness of 10? How many people said they had a happiness level of 9, 8, 7, 6, and so on and so forth? Okay? So let's fill in the frequencies here. Let's fill in the frequencies. I'm going to give you a moment to do that. If you would like, you can pause the video, and let's get our frequency in there. Okay? I mean, let me start off here. So there are 2 10s. There are 2 10s. Okay? There are 7 9s. And I'll have you do the rest. So let's pause the video. Let's fill in the rest. Okay. So 2, 7, 16, 15. Wow. So 8 was the most frequent, but boy, 7 was pretty darn close. Okay. 13 6s. 4 5s, 2 4s, 2 3s. Okay. So this tells us within the range, and by the way, check this out. We calculated the value for the range. Remember what it was? It was 8. 1, 2, 3, 4, 5, 6, 7, 8. So we can see it here. We have a range of 8. Notice as well, let's suppose that there were no 4s. So this was 0, okay? We would still have a range of 8, right? We need to include, even if there's a 0 for the frequency, we need to include that in our range. Even if there's a 0 for the frequency, we include that as part of our range. So we have a range of 1, 2, 3, 4, 5, 6, 7, 8. This tells us how many at each of these points, okay, for each of these values. Did we get everybody? Did we get everybody? How could we check that? Can you think of a way to check to make sure we got all 61? Well, if you count up the numbers in the F column, they should add to 61, right? So I mean, this is the formula, but I think it just is kind of intuitive. If we add up all the frequencies, that should add up to 10, excuse me, n. If we add up the frequencies, it should have to add up to n. So let's see, that's 9, 25, 40, 53, 57, 59, 61, okay? So if we add up the frequencies, we should get the n. Now, here's a little kind of a little bit of a fly in the ointment here. If we add up our frequencies and they add up to 61, that's cool, but I'm still not sure. Maybe there's only 6 9s and there's 3 10s, right? Then we would still have our same n. But you can always check, and this is going to be a theme in the semester. Oftentimes you'll know when you're wrong, but you won't know if you're right. Okay? If I add up all the frequencies and they don't add up to n, suppose I add these up and they only add up to 59, then I know I've made a mistake. If I add up all the frequencies and they add to 61, excuse me, hopefully I'm correct. Everybody with me? If they don't add up to n, you know you're wrong. If they do add up to n, hopefully you've got everything in the right place. All right? When you do a frequency distribution table, all you need to do is look for the highest value of f, that is the most frequent. The highest value for f will tell you what the mode is. Everybody with me? So once again, we can do the computations using formulas, and we will be doing that. But the formulas should make sense as well. Range 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. The mode is the most frequent. Let's look for the most frequent score. That's 8. You see how beautiful this is? Okay. Now, we have a data set of 61 people. If we had a data set, let's say, of 1,600 people, right? How would this look differently? Well, these frequencies would just be larger, right? So frequency distribution table is kind of cool because here's our set of 61, but if we had 1,600 numbers, this frequency distribution table would look pretty much the same, except these numbers would be higher. This might be 25, and this might be 31, this might be 127, and this might be 345, and so on and so forth. But the structure would be basically the same. Okay, so it's very powerful table. Okay, by the way, just as a reminder, if you have questions, make a little note in the margin of your notes. Drop me an email. I'm more than willing to answer questions via email. When we Zoom together, hopefully you'll have a bunch of questions. That's what I'm really hoping. Okay? And please, I usually spend the first class period, you're not stupid or dumb if you ask questions. You're really not taking care of yourself if you don't ask questions. That is, you want to do well in the course. I want you to do well in the course. And this is true for all of your courses in college, folks. I can tell you right now, faculty are frustrated often because we want students to ask questions. That is what learning is all about. You don't know something, you know something. Some of these concepts are going to be more complex than others, and I rely on people asking questions. I can answer the questions. You can say, well, what about this? And I don't really get this, and so on and so forth. If you don't ask questions, my assumption is that you're crystal clear on everything. Yikes, okay? When it comes to an exam, you need to know this stuff. So please ask questions. And you know what? You don't need to care about what other people are thinking about you. Get over that. We're in college now. That's high school stuff, at least grammar school stuff. You're paying big bucks. This is stuff that you need to know for your profession. It ain't easy. Ask questions. Ask questions. Okay, please. All right. So we're going to move forward here. And so this tells me a little bit more about what's going on, right? So we have a large chunk of people sort of in the center of this distribution. As we move outward, we're getting fewer and fewer people in the extremes. Okay? It's not the case that there's an equal number of people across each of these scores. And so this is what the frequency distribution does for us. I'm not going to do anything that's not useful. Did everybody hear that? I'm not going to do anything just for the hell of it, for the fun of it. Okay? We got too much to do. What this does is it tells us how the scores are distributed across this range. Okay? So remember I said the range informs the mean. The range tells us a little bit more about what's going on with the average. This tells us a little bit more about what's going on in the range. Okay? Getting more and more information. Now, I don't want to just throw 61 numbers at my supervisor, so I'm going to distill this down to smaller pieces. Sometimes people want to know, well, instead of just the frequency, what was the percentage of people, for example, that scored 8? I mean, I know 8 is the mode, and in this case, 16 people reported a score of 8. But that means 16 people means something different if it was 16 people out of 20, right? Than if it was 16 people out of 61, than if it was 16 people out of 200. Everybody got me? The frequency alone doesn't tell us about the proportion or the percentage of people that got that particular score. Okay? So we're going to put a couple more columns in here. We're going to put a P column, and that's going to represent proportion. And then we're going to do a percentage column, and of course that is percentage. Okay? And here is what, let's do this. Here's what I mean by proportion and percentage. It's going to be the same numerical value, but the decimal place will be different, okay? Proportion is out of 1. Percentage, percent, remember cent, like 100 cents in a dollar, or 100 years in a century, okay? Percent means per 100, okay? So, how do we get proportion? Well, proportion is, let me erase that. I don't like that little. Here's our proportion, okay? It is the frequency of a particular score. So if we're talking about the tens, it's 2 out of, that's what division means, out of, okay? So 2 out of the total. In this case, we have 2 divided by, 2 divided by 61. Okay, that's our proportion. And let me just go across the room here and get my calculator. Oh boy. Two divided by 61. 0.0327886. Okay. For proportion, folks, let's go to 4 decimal places. For proportion, let's go to 4 decimal places. Okay. So 0.03278. So it's 0.0328. Everybody got it? Do it with your calculator. 2 divided by 61. 0.03278. So I'm going to do 0.0328. 4 decimal places. Okay? Now, I'm going to move over to the percentage. So this is out of 1. This is out of 100. So from proportion, how do we get to percentage? Now, some of you learned in high school, right? You move the decimal left or you move the decimal right, or is it right? Or do you move it left? Or you move it left or you move it right? Listen, this is the problem with memorizing rules. If you forget them, you don't know what the hell they are, right? Listen, know your decimal places. This is the 10th place. This is the 100th place. So it's 3/100. 0.28. So this is 3.28%. Notice the numerals are the same. Proportion is out of 1. Percentage is out of 100. What does this tell us? I'm always, this is going to be on an exam too, I'm always going to ask you what these things mean. I'm going to ask you to calculate them. I'm going to ask you what they mean. Okay? So frequency over n, our total n, that's our proportion. This tells us what percent. So 3.28% of the people told me that their happiness was 10. 3.28% of the people told me their happiness is 10. Okay. I'm going to eventually get rid of this column, but we're going to calculate it for now because it's in the book and it's good practice. Okay. So I'm going to have you do the proportions and then we'll convert to percentage. All right. So once again, you can pause the video. Let's fill in the P column. Let's fill in the percentage column. Okay, I'm going to have you do that. So you can pause now. Okay, we're back, right? So did you fill it all in? Let's see what we have here. Let's see what we have here. Okay. Are we ready? So this one is 0.1148 for 11.48%. 11.48% of the people told me that their happiness score was 9. 26.23. Okay. 16 divided by 61 is 26.23. That's how many people told me they had a happiness of 8. And then this is 0.02459. Okay. By the way, you know, somebody might ask me this. I put zeros here. Do you have to do that? No, but you know what? People put these little dots so lightly that I like to. So I think if I put extra 0 there, it sort of enhances the fact that there's a point there. And how many people for 6? 0.2131. Oops. And of course, I'm going to have you do this on an exam, so make sure you know what you're doing here. Okay. This is 0.0656. 6.56. I'm not going to do the computations again. These two are the same as here. Why waste my time, right? Let's use our heads. Let's use our heads. The same percentage of people told me they have a happiness score of 3 as they did 10. Same 3, 4, and 10. It's all at 3.28%. Okay. So we're going to do 2 more columns. We're going to do cumulative frequency and cumulative percentage. Okay. But I'm going to pick up on that in the next video because I'm going over a little bit of time here. Plus, it took you some time to do these, I'm assuming. And so we'll do those next two columns. We will be doing in the next video. Oh, by the way, let me just go back here, okay? Remember when we put each of these numbers, on a separate piece of paper, so we had 61 pieces of paper, and each paper, so 2 papers got 3, and 2 got 4, and 4 got 5, and so on and so forth. Put them in a bucket, mix them all up. I pull out a number. What number do you think I'm holding? What's your guess? I know you don't know. What would be your guess? Well, I would guess the one that's the most frequent. 26.23% of those pieces of paper have a value of 8 on them. Everybody with me? I mean, why would you say 4? I have this piece of paper. And I say, what do you think it is? And you say 4. I'm like, why would you say that? And here's what happens. People without a college education, I'm telling you, you're paying money to be smart, okay? Why would you pick something that only happens 3.8% of the time? Somebody would say, well, it could be that. I'm like, of course it could be. It could be 3, it could be 9, it could be 10, it could be 6, it could be 5. But which ones of these has the highest percentage? 8. So my guess would be that it's the number 8. And in fact, there's 3 P's here. Proportion, percentage, and both of these relate to probability. To put it another way, if I put all these slips of paper in the box and stirred them all up, there's a 26% chance I'm going to pull out an 8. There's only a 3.28% chance of pulling out a 4. There's an 11% chance of pulling out a 9. Everybody with me? Boy, I could really increase the odds of being a correct guess if somebody would let me do 2 numbers. I pull a number out of the box and I say, I bet you it's either a 7 or an 8. What's the probability that it's a 7 or an 8? Well, more than 50%. You got more than a 50% chance, right? I'm adding these 2 together. If I pull out that piece of paper and someone says, I think it's a 9 or a 10, that's only about 14.5%, right? So proportion, percentage, and probability are related. And we're going to put that together, I don't know, in a week, okay? That's what these numbers tell us. What would the frequency distribution look like if we had 6,000 numbers in our data set? Well, we could set it up just like this. These numbers would be bigger, okay? I mean, we might have a different range, but let's just assume this is going to be similar to the range we're going to see, and then we'll have our percentages. So this frequency distribution table works if you have a data set that's 61 people, or 15 people, or 15,627, right? So very, very powerful, okay? So next video, we'll go over these next 2 columns and I'll explain what those mean. But for right now, let's just keep it there, and I'll see you guys the next time.